southern border, sir?
Not at the moment.
Have you decided when you're able to share thoughts with other countries? Is it allies or neighbors first? Who will be the first country to get U.S. vaccines?
I've been talking with several countries already. Well, I'll let you know that very shortly.
Travel to the southern border, sir?
Bruh, 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 bruh.
Mr. President, do you have any plans to travel to the southern border, sir?
Not at the moment.
Have you decided when you're able to share thoughts with other countries? Is it allies or neighbors first? Who will be the first country to get U.S. vaccines?
I've been talking with several countries already. Well, I'll let you know that very shortly.
Travel to the southern border, sir?
Not at the moment.
Have you decided when you're able to share thoughts with other countries? Is it allies or neighbors first? Who will be the first country to get U.S. vaccines?
I've been talking with several countries already. Well, I'll let you know that very shortly.
Bruh, 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 bruh.
LoopNet is the world's largest commercial real estate marketing platform, generating 69 million searches.
Crest 3D White Brilliance, 100% stain removal, 24-hour stain resistance. Lock in your whitest smile.
Okay, so time for a new chapter, time for a new section 7.1. So far, what you know about integrals is that you can basically do two things. If it fits your integration table, you are good to go. If it doesn't fit your integration table, the only thing that you can do with it is what? Substitution. To make it fit. That's right, substitution to make it fit the table. Right now in chapter 7, we're going to learn a whole lot of other integration techniques that you haven't learned before, unless you've had this class before, that you haven't learned before. So have you ever wondered, there's a substitution that's kind of like the chain rule, right?
Yeah.
Substitution is like the opposite or inverse of chain rule. Have you ever wondered why there's not a product rule?
Mm-hmm.
There's a product rule for derivatives, isn't there?
Yeah.
Is there a product rule for integrals?
Not that I know of.
Not that you. I want to show you something. Do you know what that is?
The product rule.
From product rule. I'm going to prove something for you. And we're just going to start with what the product rule is, and we're going to try to undo it. So notice that we've got a derivative, and the derivative equals derivative of the first times the second plus the first times derivative of the second. That's your basic old product rule. Now, what's the inverse of a derivative? Let's integrate both sides. We can actually do this. You can integrate both sides of the equation. So if we integrate this dx and integrate this dx, then what we end up getting is the integral of the derivative of f of x times g of x dx. And over here we got the integral of f prime of x g of x plus f of x times g prime of x. You guys okay with that so far?
Yeah.
Just take an integral on both sides. Now, let's see what happens here. What is going to happen here if I take the integral of a derivative?
Better do it so.
Yeah, calculus tells us that. They are inverses. So if I take the integral of a derivative, dx, okay, that's gone. All I'm going to have is f of x times g of x. Does that make sense to you? Are you sure?
Yeah.
Now, the next thing I'm going to do, I'm just going to separate this. Notice that with integrals, you can separate by addition or subtraction. So I'm going to do that. I'm going to have the integral of f prime of x, g of x, dx, plus the integral of f of x times g prime of x, dx. So we had product rule. I just take the integral of both sides. No big deal. Derivative is gone. Integral and derivative, they basically undo each other. They're inverses. I have just the functions themselves, f times g. Here we know this was product rule. If we break up our integral after doing an integral on both sides, we have one integral. We got two integrals. You guys with me? I'm going to solve for this one. I'm going to put this on one side. Basically, I'm just going to subtract that guy. Does that make sense? Okay, so f times on integral and derivative, they basically undo each other. They're inverses. I have just the functions themselves, f times g. Here we know this was product rule. If we break up our integral after doing an integral on both sides, we have one integral. We got two integrals. You guys with me? I'm going to solve for this one. I'm going to put this on one side. Basically, I'm just going to subtract that guy. Does that make sense? Okay, so if I do, then we've got integral of f of x times g prime of x dx equals, I'm going to keep this, and if I have subtracted that, I'll have f prime of x times g of x dx. Are you guys okay with the algebra on that one? I'm going slow. That I want to make sure you really do follow it. Do you follow it? There's only one more thing that I'm going to do. What I'm going to do right now, I'm just going to switch these two guys around. So by the commutativity of multiplication, this is not a problem. I'm going to put g of x before f prime of x. You okay with that one? Okay, so integral of f of x times g prime of x dx equals, let's see, f of x, got that, times g of x, no problem, minus integral of g of x times f prime of x dx. Okay, I want to show hands, feel okay with that so far. Now, that's just some algebra after doing a little bit of calculus. All we did was do an integration on both sides. What in the world does it all mean? Well, I'm going to show you, because right now it's a little hard to understand. We're going to use some symbols right now to represent some of these functions. So what we're going to do is we're going to call u we're going to call f of x u, and we're going to call g of x v. Please keep in mind, u and v are going to represent functions in your integral right now. They're going to represent some functions here. So we're letting u represent the function of x, v represent the function g of x, a function of x. You guys okay with that so far?
Yeah.
Now, we got some other things besides just f of x and g of x, don't we? I mean, we could change this to a u right now. You with me? We could change this to a u. We could change this to a v. We could change that to a v. You with me? However, we've got an f prime, and we've got a g prime. So what we're going to do is go, okay, cool. Well, tell you what, let's just do like a du. Let's do a derivative on both sides. If I do this just like your substitutions do, derivative of u is our du. Derivative of f is f prime of x, dx. Do you remember doing that?
Yeah.
Just like a substitution. Well, here we'll get dv, and we'll get g prime of x dx. You still okay with it? Now look, every one of these pieces is now part of this little box of knowledge. Let's do a substitution. Instead of f of x, what are we calling it?
U.
No, f of x is just u. What is this piece? G prime of x dv. That's our d. So this is dv. F of x was u. G prime of x dx, dv. You guys okay with that so far?
Yeah.
Equals. What's our f of x again?
U.
What's our
V.
So f of x is u times g of x is v minus integral. What's our g of x?
V.
Now this is kind of cool. What's our f prime of x dx? This whole piece. So if we integrate the product rule, what we end up getting is this thing right here. What this thing is how to do integration by parts. Just like the product rule is a formula, right? It's a formula. Just like the product rule is a formula, it's been proven. Just like the product rule is a formula, integration by parts is also a formula. And even though it looks a little like, what in the world are we doing? I'm going to give you some easy ways to do some of these integrals. You guys want to see how this stuff works?
Yes.
Firstly, do you see how the formula comes about?
Yes.
I don't want to just give you that. It's like, what in the world? This stems from the product rule. It's an easy proof, but that stems from the product rule. Let me show you why we do this. So integral of x times e to the x dx. So this right here, what's this called again? Maybe you write that. This is integration by parts. So when I say do integration by parts, or when the book says do integration by parts, or your best friend says at one of your parties, hey, can you do some integration by parts? You're like, yeah, duh, I know what that means. That'd be the best party ever, by the way. So, my kind of party. So let's look at this for a second. Think through all the things you know about integrals. Does that fit your integration table the way it is? No. This would, that'd be easy. That would, that'd be easy. But this, can you use a substitution?
No.
If you pick this to be u, the derivative is 1. Does it get rid of the x?
No.
That's a problem. So will a substitution work here? No, there's no way to do this integral for us right now. We had to create something new that would take care of it, and this is what we have. You see, when you have a product here, we use the product rule. Sometimes when we have products here, we can use for integrals integration by parts, which is really, really cool. Let me show you how this works, and let me show you what you should be picking for u and for v. By the way, it should be really apparent whether you pick the correct thing or not within about the first step or two, all right? So here's how, in general, you choose how your u and how you choose your v. So a couple little notes. I want you to choose u so that you can take the integral of whatever v is, basically the integral of the rest. It'll make sense in just a second. I'm gonna write out the notes right now, write them down, and I'll explain it. So choose u such that, or so that, the integral of v is actually possible. And try to pick u. This doesn't always work, but this is a good indication. Try to pick u so that the derivative of u is better, so that it's smaller or easier to work with. So choose u so that the integral of v firstly is possible, because you're going to have to take the integral of v. Also, and try to pick u, so that the derivative of u is better. Better, I know that's not mathematical, but better as in you reduce the power. It becomes smaller. It goes away completely, something like that. So here we go. I want you to look at this integral with me. There's two parts to this. There's an x part and there's an e to the x part. You with me? Okay, if I pick u to be e to the x, is the derivative of e to the x better?
No.
No, it's still e to the x. I could take the integral of x. That's okay. But if I pick x, what's the derivative of x? Is that better?
Yes.
Yes, 1 is better than x, isn't it? I think so. I'd rather work with 1 than x. Seems better. Also, can you do the integral of e to the x? Then that's our appropriate pick, our appropriate choice for you. So here's how we do this. It's going to take some getting used to, but here's how it works. Pick u so that you can take the integral of the rest, your v, and pick u so that hopefully the derivative of u is going to be better, easier to work with. Do you follow that? So in our case, we're going to pick u equals x. Here's what v equals. It's really easy to find. There's an easy way to do it. What's your u? Cover that up with your hand. V is all the rest of it. So v is the integral of e to the x dx. The reason why we have that is because we're going to have to deal with the integral at some point. We have to have our v equals the integral of the rest. We need to be getting, let's see, what are we trying to get there? We want to be able to find our v for this guy. We got to have that. So can you do your, just like you're doing a substitution, can you do your du?
Yeah. Sure.
How much does your du equal?
Yeah.
Okay. V was the integral of the rest. Can you do the integral of e to the x?
Yeah.
How much is it?
Yeah.
Don't worry about the plus c right now. Don't worry about the plus c right now. We're going to deal with the, say what?
Oh, V.
No, we're just, right here, we're not doing a derivative. We're saying v is the integral of the rest. Okay, we're not doing derivatives here. We're actually doing the integral of this thing. So v is the integral of the rest. That's what v is. So, okay, do the integral of that. V is now e to the x. You with me? Okay, cool. Man, do we have the parts? Do we have what u equals?
No.
Do we have what v equals?
No.
Do we have what v equals?
Yeah.
Same thing. Yes. Do we have what du equals?
Yeah.
Put it in the formula. So what our integral is then is u times v minus the integral. Notice there's another integral. You do integration twice here. One to find the v, and then again in your formula, e to the x. I'm sorry, what was the du?
Dx.
That's the idea. I need to make sure this makes sense to you. So we're picking u, so then the derivative becomes easier, and you can do the integral of the rest. The easy way to do this: identify what your u is, cover it with your hand. V equals the integral of the rest. That's what v is for us. That's the easy way to do it. After that, well, find the derivative of u, derivative of x. Du equals dx in this case is a really easy one. Do the integral of whatever you had left over. So that's e to the x. Now put it in the formula. Integration by parts says integral of u dv equals u times v minus the integral of v du, dx in this case. Now, can you do that integral? How much is it?
Yes.
So we get x times e dx minus what? This, when you finish that last integral, that's where you do the plus c. You see, you could get a constant here. You could, but we don't need to because you're saying integral of constant plus a constant, we just get another constant. So we have a plus c here. You guys all right with that one? Tell me one more thing that we could do.
Change it again.
We could factor in e to the x. A lot of times with e to the x you can factor it. So what we know is the integral of x e to the x dx actually equals x e to the x minus e to the x plus c, or e to the x times x minus 1 plus c. Either one of those things. Show of hands if you can follow that one. You're probably gonna need some more practice, right?
Yeah.
Okay, because right now this is only the first. This is about the easiest that we can do. They get a lot more intense, I should say. Not really a different idea. It's the same idea. If you can't do the substitute, by the way, when you're doing integrals, don't jump immediately to integration by parts. Go through your list. If it's integration table, that's the easiest, and just do it. If it doesn't, you try what first?
Substitution.
Please try a substitution, because if you can do a substitution, that'll be easier. After that, then you try stuff like integration by parts. Then you try a trigonometric substitution, which we haven't covered yet. We're going to cover that in this chapter, but it's later on. So let's try a few more examples. We're going to start building these up to more and more intensity. That way you get used to doing some of these problems. I don't want to give you just like spoon feed you and then on your test just hammer you with some hard ones. So we're going to do some hard ones here in a little while, but I want to get you used to this first.
Well, I've been afraid of changing, 'cause I built my life around you.
So how about, I'm also going to try to make some mistakes. That way you can see the appropriate choices and when you will realize that you've made the wrong choice. Does that make sense to you? You go, oh man, that's what happens when you make the wrong choice here. So, okay, we'll take a look at it. Now, the first thing we always check for, what is it when we check integrals? What do we check for? We check to see if it's actually in the table first. Is that in your table? Heck no, most of them aren't going to be okay, otherwise it'd be real easy. After it's not in your table, what do you try to do? Now you try to do a U sub. Is a U substitution going to work here?
No.
If I pick this, the derivative is x squared. Do you see an x squared anywhere?
No.
If I pick this, that's 1 over x. Do you see a 1 over x anywhere?
No.
The substitution is not going to work. Okay, well, if the substitution doesn't work, our next go-to, this is the model of thinking that you do, okay? Does it fit the table? If it does, awesome. If it doesn't, okay, substitution. Does it fit substitution? If yes, cool, that's pretty easy. If not, dang it, then we got integration by parts. It'll still work, it's just a little bit more work. So go through and try to pick the appropriate thing, the appropriate factor for your integration by parts. So we got two choices again for our U. Our U could either be x cubed or it could be ln x. What would you pick for your U?
3x to the third.
Why not x cubed? Let's think about it. I want to show you though. Check this out. Let's say that I picked, you can write this down or not, I don't really care. Let's say you picked U equals x cubed. You with me? If you pick U equals x cubed, can you please tell me what your V would be?
Ln.
No, it's not just ln x. Don't forget that integral. My goodness, don't forget that. It's the integral of ln x dx. It's all of the rest of the stuff. Does that make sense?
Yeah.
You're basically just covering up the U. The U is one part. This is your U. V equals all of the rest of the stuff. So V equals, quote unquote, the rest. Show of hands if you feel okay with that. It's a big deal. All right. Now, could you take the derivative of this?
Yeah.
We can take the derivative of darn near anything. And that actually makes it easier for this one. Can you take the integral of ln x? You can? What is that?
The 1 over u. 1 over u du.
Okay, I'm not asking for the derivative. I'm asking for the integral.
1 over
The derivative of ln x is 1 over x. What's the integral of ln x?
e.
No, it's not e.
Oh.
Well, I don't know. What is it? Can you do it?
Can't actually.
Then if you can't do it, then we've picked the wrong thing. Does that make sense?
Yeah.
You need to pick, listen. This is not a trivial point here. You need to pick u so that hopefully the u becomes better, the du makes it better. But if not, okay, the main thing here is that you can actually do the integral of v. Because if you can't, then you're stuck. None of you right now, unless you've had this class before, know what that integral is. Do you know what the integral of ln x is? No, you don't. So we made the wrong choice. This is a bad choice. Well, if that's the bad choice, don't beat yourself up over it. Just erase the problem and pick the different thing. What should our u actually be? Okay. What you said all along, genius. So if u equals ln x, can you please write down what the v is going to equal?
So that'd be 3x squared.
No, it wouldn't be 3x squared.
Integral x cubed.
We still got an integral, don't we? Listen, I'm not lying to you. All you do is cover this up, cover that up, your u, and write the rest. Whatever you see, that's what goes for your v. It even rhymes. Don't you love rules that rhyme? Whatever you see is what goes for your v. That's stupid. I should edit that. I'm not going to. You can watch it go. Yeah. I feel victorious right now. Can you take the derivative of this guy?
Yeah.
Okay, what's the derivative of ln x?
1 over x.
Hey. The only thing where the derivative equals the integral is when you're dealing with e to the x. Okay, that's it. ln x is different. So we get 1 over x.
Yes.
Ah, good. Now, with the v, we're not doing derivative here. We're actually solving this integral. Can you do the integral of x to the third? Then we picked the correct choice here, okay? The other choice didn't work. This choice, we get x to the fourth over 4, or 1/4 x to the fourth. I don't care how you put that. We don't need a plus c, because we're just using this in our formula right now. We'll have the plus c at the very, very end. Show if you feel okay with that one, and do you understand why we picked the u the way we did?
Yeah.
Good, that's important. That's the hardest part of this, is picking the u correctly. Honestly, it is. The rest of it is a formula which you know how to do. You know how to do easy integrals. You know how to do all sorts of derivatives. You're good to go. Just use the formula. So what the formula says is that the integral of u dv equals u times v minus the integral of v du. Just plug in the pieces. Watch this real careful though. Make sure you plug in the pieces correctly. Can you please tell me what the u is? Good, right here. That's our u. Times our v. Do the v that you actually solved for. Don't put the integral again. What's the v?
X to the fourth over 4.
You guys okay on the u times the v? We got a minus sign, put a minus sign. We got an integral sign, put an integral sign. Put the v here again. The v goes in 2 spots. V goes here, v goes here. Now, stick with me. ln x, x to the fourth over 4, minus sign. Got it. So ln x, x to the fourth over 4, minus sign. Integral, x to the fourth over 4 again. That's our v. Now, look at your du. Your du is not always dx. Your du depends on what you picked for your u. What's your du?
1 over x.
So we need 1 over x dx. It's different than substitution. It's different. You don't start solving for the dx here. The formula says you're going to take this and put this whole thing where this is. You don't start solving for that, like some people do, like I do for substitutions. So if your u is ln x, put that. If your v is x to the fourth over 4, put that. Minus, no problem. Integral, no problem. V is x to the fourth over 4, put that. Du is 1 over x dx. Show of hands if you understand the concept. Good. Now, simplify it. Solve it. This should be solvable. If it's not solvable, listen carefully, please. If this isn't solvable, it's the only piece of calculus you have left, right? If that's that's not solvable for you, if you can't do that, try a substitution. Or try another integration by parts. If this thing explodes way bigger than this thing, then you've picked the wrong choice and tried the other substitute, try the other u, okay? So you shouldn't be making these way, way worse. They should start getting better, smaller powers and things like that, okay? Or a doable integral. This one actually get the same power back, but we can do the integral. So in our case, we got ln x times x to the 4th over 4 minus the integral. What are you going to do with all this stuff? Tell me something you can do.
Combine.
Combine. How much do we get?
X to the 4th over 4x.
Not x to the 4th. No.
X
X to the 3rd, yes. And then we can also do what?
Bring the 1/4 out.
Maybe 1/4 out front would be a good idea. Hey, does that look like something you can do?
Yeah.
I sure hope to goodness that you can. I mean, that should be an easy one. You guys okay with the algebra on that one?
Yeah.
1/4 comes out. X to the 4th. You should know how to simplify here. So let's keep after it. This one I'm going to write a little bit different because I don't like having my ln x first. So I'm going to write 1/4 x to the 4th ln x. Y'all okay that that's the same thing? 1/4 x to the 4th ln x minus 1/4. Hey, look at that. Now we can do an integral of something that's really, really, really easy. What's the integral of x to the 3rd?
1/4.
In fact, we already did it.
Yeah, I think 1/4.
Now is where you put your plus c. Is the plus c important?
Yeah.
Yes. Don't forget it, okay? So don't do all this work and then go, I'm done. No, you're not done. Put the plus c. Let us know that happens. So 1/4 x to the 4th ln x, no problem, minus 1/16. See where that comes from?
Yeah.
Yes, no, everybody.
Yeah,
X
to the 4th.
X to the 4th.
Let's see.
Could you do some other things with it?
Factor out x to the 4th. Oh, x is 1/4.
You can do
x
a
to the
lot of
4th.
things with this, okay? You could factor in x to the 4th. You could actually force this thing to factor out a 1/16 or a 1/4 or a 6. You could factor out a lot of stuff here. So if you did, it's going to look a little different. So keep in mind when you look in the back of your book, if it looks different, they might have just started factoring things. So don't give up on it. If you're, man, I think I'm right, try factoring something. See if you can see a common factor that they have. Okie dokie. So if you feel okay with that one. Can we build it up just a little bit? Okie dokie. Okay, I'm going to change this problem slightly in just a moment, but I want to ask you a question first. What do you check first when you're doing
in your table.
integrals? Table, okay, good. Does it fit your table?
No.
Next, you check for,
Substitute.
will a substitution work here?
No.
Look again, will a substitution work here? Absolutely.
Yeah.
Because the derivative of this is 6x squared. Do you see it? Your x's are gone. So if I give you this problem, this is my whole point, which some of you obviously didn't listen to. My whole point is do not jump automatically to that. That's silly, okay? Try a substitution if it'll work. Here, don't do this problem. I told you I'm going to change it in a minute. So this would be great for a u sub. U equals this, derivative of 6x squared. X squareds are gone. You pull out a 1/6. You're basically done. You're going to get negative cosine. 1/6 negative cosine of 2x cubed, if I'm right. Plus c. Done. Easy. Will a substitution work now? No. No. So what are we going to do? The next one. You always check a substitution before you check integration by parts. I hope that I'm getting through to you right now. I'm getting through to you right now. Always check that because it'll make it easier if it'll work. So, oh man, let's see here. What's a good choice? What do you think? Sine 2x. Well,
2x.
if we think Say what now? If we pick sine 2x as your u, does the derivative get better?
No.
And the integral grows, right? Squared x to the third, okay. So in your next process, you would have a cosine somewhere, and you'd have an x to the third. Your integral is going to explode a little bit. Does that make sense? I'll show you if you want. I think we have time for this. If you did, don't write this in the, well, I'm going to leave it up here, but you can if you want, I guess. If you did this, oops. That would be it, wouldn't it? U integral the rest of it. So that would be du equals 2 cosine 2x dx. Do you know why I have a 2 up front?
Because the chain rule.
X to the third over 3. Then I'd have uv minus integral of v du. This is my du.
Yeah.
Do you see what I'm talking about? Right when you do this, you should give up. Okay? Not calculus, all right? But right when you see this, look what happened. Look at, honestly, look. This is basically the same thing, but my power grew. It didn't get smaller, it grew. Is that a good thing?
No.
Then this is the wrong thing to do. So don't try to manhandle this problem and pound it into submission, because it's going to kick your butt, all right? This thing's going to get worse. If you pick this again, well, then it's going to go to a 4. And then that's silly. So we don't want to do that. So this is a bad choice. You understand what's a bad choice? Integral got worse, not better. Even though you could do the integral of this one, this derivative didn't look better. You want both, really. You want the derivative to be better, and you want to be able to do the integral. So let's try the other one. Instead of this being u, let's pick that one being u. Then v equals, cover it, integral of the rest. du equals, this is easy part, du equals 2 dx. You guys okay with the du equals 2 dx?
Yeah.
Now, listen, you should be able to do this other thing, this other integral. Can you do this integral?
Yeah.
You might have a u substitution in there. So if you would do a simple u sub, I wouldn't pick u because you already have a u. I'd pick like a w or whatever you want, anything that you want besides x, v, and u right now. So if you picked a w substitution equals 2x, dw equals 2 dx, dw over 2 equals dx. And then do your substitution. What you're going to end up with after you do this a whole lot is you're going to understand that really what this v is going to be is negative cosine 2x over 2 is what that's going to be. Do you guys see where the over 2 is coming from? The over 2 is coming from when you have your w equals 2x, dw equals 2 dx, dw, oh, look at that, over 2. That's where the over 2 is coming from. No?
Yes.
Did I blow your minds? Did you follow that?
Yeah.
Do I need to do the whole thing for you?
No.
No.
Okay.
1/2 negative cosine w. W is 2x. That's that. That's all that. Okay, now w. So we've done our u, we've done our v. Let's put this thing together in the formula. The formula should look. You tell me, what's the first thing I should write here?
X squared.
Good.
Squared times
Times.
v negative cosine 2x over 2.
Minus the integral.
Minus the integral of negative cosine 2x over 2. Times 2x.
Times what?
2x dx.
I'm gonna erase this. Hey, show of hands if you're okay with that one so far. Yes, yes, guys in the middle?
Oh, yep, so yeah, absolutely.
Let's clean it up before we go any further. That's nasty, all right? Let's make this negative 1/2 x squared cosine 2x. Negative 1/2 x squared cosine 2x. Let's do a couple things here. Let's pull out this negative and make that a plus. Let's pull out this 2 and simplify it with this 2. Can you guys see that?
Yeah.
2's are gone. Let's make it plus integral cosine 2x times x dx. You could even, if you want to, move the x out front right here, x cosine x. That might look a little bit better. Let's change that. So x cosine 2x. Okay, well, show of hands if you're okay with algebra on that one. Now, calculus is done. Just like you follow your ddx with derivatives, follow your integral for integrals. So here, can you do that anywhere?
Yeah, you can.
Is it in an integration table? Is a substitution going to work?
Yes.
Okay, what's the derivative of 2x?
2.
So you need another part?
You need an x, right? Would this work? Yes, if it's a square. Is a substitution going to work here?
No.
No.
Another
Oh my god. Okay, so we did. Is it in the table? Will a substitution work? What's your next choice?
No.
You can do it again. Are you kidding? Now, don't screw this up. Pick the same thing for you that you did here. The same thing. It should be reduced by a power. Do you see that? This is basically the same, except instead of x squared, you get x. That's how you know you did it right. Okay, this should at least go down a power. If it goes up a power, you pick the wrong choice. If it goes down a power, you pick the right choice. You just got to do it again. So let's do it again. Lots of practice. So we're going to hang on to this, okay? We're going to look just right here. We got to move quickly. What's the appropriate u? Check this out. When that's x, see how when we take a derivative, the power drops, doesn't it? 2 to 1, 1 to 0. That means that our next integral would be very easy. Our next integral would be possible at least. So v would equal the integral, cover it, integral of whatever's left, cosine 2x dx. I'm going to do this integral quickly. I'm not going to show you the substitution like here. Do you see that you're going to have another substitution here? U or W or whatever, it's going to be 2x. That means dW is going to be 1/2 dx. That means we're going to get an over 2. So this would be sine of 2x over 2. Can you verify that for me? Sine 2x, but then over 2 by the substitution rule. Okay, so I would not write this again right now. I'm just going to hang on to it. I'm just going to focus right here. So I'm going to have a plus, big old stuff, plus, well, we're going to have u times v u times v minus the integral of v du. Now, what's our du in this case? That's nice. That means that we're not going to have any extra work to do. I want you to see if you're okay with this one. I know I'm going about a minute or two over, but this is kind of important for us. You okay with the u? Du's dx now. You okay with the v? V's the integral of the rest. Pretty easy integral. You need to be able to take these integrals, otherwise you made the wrong choice. Now we got u times v minus the integral of v and then du. Du is dx. Make that substitution again. Tell me something we're going to do with this. Okay, so if we do that, we get some stuff plus 1/2 x sine 2x minus the integral. Oh yeah. Yeah, that's okay. 1/2 integral sine 2x dx. Only we've already basically done that one. Look at this. This integral is that integral. So just look back at your table. We've already done it. So we have all the same stuff minus 1/2. This again was negative cosine 2x over 2. Exactly what we have here. This integral is the same as this one. So negative cosine 2x over 2. Show of hands if you're okay with that one. Now we're just going to clean it up. Okay, just cleaning this thing up. We've got All that nasty stuff was negative 1/2 x squared cosine 2x plus 1/2 x sine 2x. What happens here?
Two cancel out.
Twos do not cancel out here.
Oh, sorry.
Plus 1/4 cosine 2x, and last little bit. Easy. Okay, I want to make sure you're clear before I let you go. This is the first little part. It's right there. Do you guys okay on that one?
Yep.
From the first integration by parts. This was the first part of our second integration by parts, the u times v. This little piece, this plus, comes from when we do our last integral. Minus and negative becomes a plus 1/4 cosine 2x plus c. Oh my gosh, look what happens to the powers. Square to the first power, no x at all. That happens a lot when you have this. If you add x to the third power, you have to do that one more time. If you add to the fourth power, you have to do it one more time. Ultimately, we're going to find a reduction formula for that. We're going to create our own formula for this. What I want to know is if that actually made, I know this is kind of sloppy, I didn't have room over here, but you understand that this is the plus 1/4?
Yeah.
Show of hands if this made sense to you. Good.
First year driving rideshare. TurboTax made filing extremely simple, and having a live expert go over the forms is great.
All right, so for our day today, we're going to practice more integration by parts. So if you don't remember from last time, no, had a weekend in between this, except for people watching online, they have like 5 seconds
Everything that guy just said is bullshit. Thank you.
Pastries a la Lizzie deserves coverage a la Lizzie. Insurance designed.
To support local restaurants, we've been to every.
Pastries a la Lizzie deserves coverage a la Lizzie.
Sustain guitar from dead mountain in mid moon poplar. Disgusted with your house, defensive, spotted and lost blood. Will come midnight, thousand concrete cows, loving, feline, feeling, the streets are uncaring, feeling, unspeaking, unseen, tired. Only child in his head, taken leading me there by thoughts again. Even though I can see me, time is living, clouds
Standing right, we're flying over the clouds. As the daylight now dies, our stereo breathing. Endless to the chasers, our demons high tops, waiting for feet of the ground. It's passing down. Steady and right, she's bringing out from the ground. Like the smell of my hair, blue stars always right. So fast, it was broken. The feeling's broken. So we just let it fade. Is it time?
For some reason, your baby falls asleep whenever reggaeton plays on YouTube Music. Strange? Maybe. But you're thankful for whatever puts your baby to sleep. Now, you're just hoping they don't wake up during this ad. Upgrade to YouTube Music Premium and get uninterrupted ad-free music. More non-stop reggaeton, more non-stop sleep. Start a trial on us. Terms and conditions apply.
I'm Anil Kumar. Let me first thank Yusuf, my subscriber, to share a few questions with us. This is a question on inequalities which involve two square root terms. The question here is, solve square root.
To solve, you need to equate. So one of the solving is we first have to take into account the domain that we have in our problem, because we don't want any numbers to appear in our solution set that will cause this x plus 7 in this case, the part that's under the square root, to become a negative number. Because if we allow that to happen, then we'll have an answer that will not get a real answer, or we'll have a number that will not get a real answer, which meaning it's going to pull a little event or equal a little to use the end this domain. Any square root of p is everything on the left are this, and I'm going to 7 on that side, and 3 squared is 9. And all I have at this point, except if you ever, so 7 goes away on the left, 9 minus 7 is 2, and That is my solution, as long as it doesn't cause any numbers in the solution do not violate the domain that I established on the right side.
Those emotions, they were put on hold by time, but at Claire's bridal weekend at a Verbo beach house, those emotions also made the trip.
We made USAA insurance for veterans like Martin. When a hailstorm hit, he needed his insurance to get it done right away. USAA, what you're made of, we're made for.
The Black experience is rooted in creativity. We can see Black history through music, comedy, dance.
When school isn't a place you have to be, why not go to school where remote learning can be as remote as you want?
These are some plants I found hiking. Here we have a pine cone. And then... Wait, don't touch it!
There's a 3, not a P.
Oh, yeah.
Whatever kind of vacation your family needs right now, find it on Vrbo.
Here you are, sipping tea, listening to great music, just taking a break from all the busyness. You deserve this. But wait a minute, is this an ad interrupting your me time? Yes? Yes, it is. Upgrade to YouTube Music Premium on your app or online for ad-free music. That means more of this, and absolutely no more of me. Sorry for the whole interrupting your peace thing. Get a 1-month trial on us. Terms and conditions apply.
Business in the front, business in the back. The all-new 2021 Ford F-150 with new available interior and tailgate work surfaces.
Electric fields can induce dipoles in insulators. Electrons in insulators are bound to the atoms and to the molecules, unlike conductors where they can freely move. And when I apply an external field, for instance, a field in this direction, we have often talked about power supplies, which are devices which maintain a constant potential difference. Here we have such a power supply, potential difference V, this be the plus side, and this be the minus side. I'm going to connect this. I have a resistor here, R, and as a result of this, a current will start to flow in this direction, this direction, this direction. So in the power supply, the current flows in this direction. Through the resistance, the current flows in this direction. In what direction is the electric field? The electric field always runs from plus to minus potential. So right here in this resistor, the electric field is in this direction, from plus to minus. But inside the supply, it must also go from plus to minus. And so inside the supply, the electric field is in the direction that opposes the current. So some kind of a pump mechanism must force the current to go inside the supply against the electric field. A boulder does not all by itself move up a hill. And so something is needed to push it. You remember with the Van de Graaff, we were spraying charge onto a belt, and then we rotated the belt, and the belt forces the charge into the dome. It had to overcome the repelling force of the dome. So work had to be done. So the energy must come from somewhere. And in the case of the Van de Graaff, it was clearly the motor that kept the belt running. In the case of the Wimhurst, it was I who turned the crank. So I did work. In the case of common batteries, the ones that you buy in the store, it is chemical energy that provides the energy. And I will discuss now with you and demonstrate a particular kind of chemical energy, which is one whereby we have a zinc and a copper plate in a solution. So we have here H2SO4, and we have here zinc. plate, and we have here a copper plate. This side will become positive, and this side will become negative. You will get a potential difference between these two plates. To understand that really takes quantum mechanics. This goes beyond this course. But the potential difference that you get is normally something around 1 volt. The secret really is not necessarily in the solution, because if you take two conductors, two different conductors, and you touch them metal on metal, there will also be a potential difference. So let's look at this now in some more detail. We have here a porous barrier that the ions can flow freely from one side to the other. And we connect them here with a resistor. And so a current flows freely from one side to the other. And we connect them here with a resistor. And so a current is now flowing. A current is flowing from the plus side of the battery to the minus side. That means inside the battery, the current So you see again, as we saw here, that the electric field is in the opposite direction of the current. You will have here SO4 minus ions